It started as heavy industrial plate steel, built to be a fantasy display piece, but a true blade has to prove its structural integrity. Here is how a massive replica became a functional weapon. The goal is a massive, battle-worn sword built from raw steel. After plasma cutting the heavy profile and welding intricate copper wire, the structural foundation is set. Now, the steel must be hardened. The blade is heated until it glows, then rapidly plunged into a quenching bath. This thermal shock freezes the steel's crystalline structure into a rigid matrix, locking in its strength. The resulting surface scale is ground away, leaving clean metal ready for a controlled aging process. A liquid chemical patina is brushed over the steel and cured with a blowtorch. This oxidizes the metal, creating a deep, protective black layer that forces the raised copper scrollwork to stand out in sharp relief. Contrast is what gives a fantasy weapon its character. But dark steel alone doesn't cut. An angle grinder strips the patina from the perimeter, exposing the raw, hardened edge. The transition from forged black center to polished bevel defines the blade's geometry. The steel is finished. To cast the ornate hilt, the builder relies on traditional sand molding. A hand-carved fiberboard master pattern is pressed firmly into a bed of red casting sand. This specialized granular mix holds extreme detail under pressure. A dot of fine blue release powder ensures the wooden pattern can be removed later without tearing the mold's fragile walls. With the frame clamped tight, the cavity is ready for the pour. Inside the furnace, raw metal has been brought to a fluid, glowing state. Lifting the heavy crucible requires steady hands, as molten brass is unforgiving. As the liquid metal floods the sand cavity, small flames erupt from the mold vents. This is a critical reaction burning off expanding gases that would otherwise create porous, weak spots inside the casting. The remaining metal is poured off into ingot trays to cool. Timing the release is a matter of thermal intuition. Opening the frame too soon risks warping the hot metal. Once the heat dissipates, the sand falls away to reveal a solid, golden hilt. The fiberboard pattern has successfully translated into a permanent cast. The raw cast is accurate, but still carries the waste material of the process. A bandsaw slices away the thick pouring sprue, separating the functional piece from the casting channel. Even the finest sand mold leaves a slightly rough texture on the metal surface. A high-speed rotary tool dives into the recessed pentagonal emblems, grinding away the granular finish to expose solid brass. Finally, a heavy drill press bores a precise mounting hole through the center axis, creating the channel where the blade's tang will eventually anchor. Before assembly, the hilt's geometry must be refined. Hand files remove the harsh burrs left by the cutting tools, leveling the edges to a uniform thickness. Running the flat faces across a sharpening stone guarantees the mating surfaces are perfectly flush. To achieve a final mirror finish, the piece is driven against a rapidly spinning buffing wheel. This uses micro-abrasives to erase microscopic scratches and pull the inherent luster out of the brass. With the polishing complete, the golden hilt is threaded onto the blade's welded tang. The components lock together, merging heavy industrial steel with refined casting. After turning a decorative pommel on the metal lathe, attention shifts to the grip's finer hardware. The builder clamps a grooved brass cylinder into the vise, slicing off a narrow, textured section with the bandsaw. This small ring requires careful deburring on the belt sander, ensuring it will sit perfectly flush against the wood without splintering the handle. The machined groove serves a specific purpose, acting as a structural bezel for a faceted red gemstone. Sinking the gem into the brass housing protects its fragile edges from impact while keeping it prominently displayed. Threading a final retaining nut onto the base of the wooden handle locks the brass spacers, the gems, and the grip under constant mechanical tension. The hilt is now rigid. The sword requires one more heavy piece of hardware to complete its guard. Using the same foundry setup, another crucible of molten metal is prepared. The heat required to liquefy this volume of brass demands constant monitoring and stirring to prevent impurities from pooling at the surface. Pouring the liquid into a second sand mold fills a thick, shield-shaped cavity. Sand casting is an ancient and messy process, prioritizing bulk material transfer over immediate surface perfection. When the piece is finally pulled from the dark, burnt sand, it appears heavy and crude. The true shape is buried under a crust of oxidized residue. Transforming the rough cast into a polished shield component follows a familiar sequence of heavy stock removal. The bandsaw shears off the thick casting sprue, while aggressive hand files strip away the burnt exterior to reveal the golden alloy beneath. Because this piece must integrate seamlessly with the rest of the handle structure, precision is critical. A milling machine drops a perfect vertical bore into the solid brass. Using a hand tap, the builder slowly cuts internal threads into the freshly drilled hole, allowing the heavy shield to act as a massive locking nut for the entire assembly. A final pass with a rotary engraver adds texture, before the buffing wheel pulls the metal up to a flawless, mirror-like polish. The final visual accents are fabricated from synthetic materials. Pouring liquid blue silicone over rigid diamond-shaped masters creates a flexible, reusable mold. Silicone captures microscopic surface details and releases easily, making it the ideal negative for casting plastics. Two-part red resin is mixed and poured into the flexible cavities. As the chemical reaction hacks off, the liquid cures into a solid, translucent plastic with the hardness of a decorative stone. The resulting gems are completely uniform and highly durable. A permanent adhesive bonds the flat backing of the resin gem directly to the polished brass shield, adding a stark flash of color to the heavy metal hardware. The assembly is complete. Dark, etched steel, heavy cast brass, and synthetic rubies have been merged into a single cohesive artifact. But a weapon built solely for display is just heavy jewelry. The ultimate test of the forge and the casting process is structural integrity. A cleanly severed pineapple proves the blade's edge geometry is sharp and true. But shattering a solid masonry brick proves something far more important. It proves the hidden welds held tight. It proves the heat treatment locked the steel's molecular structure without leaving it brittle. The impact forces are transferred flawlessly from the edge, down the tang, and into the handle without failure. In the end, true craft is about making something that works just as well as it looks.